Assalamualaikum. My name is Aisha Maqsood and today I'm going to discuss half header and full header with you guys. But before discussing half header and full header, I'm going to discuss that what are basically headers. So header is an in kind of calculator that is used to add two binary numbers. When I say calculator, I don't mean one with the buttons. This one is a circuit that can be integrated with many other circuits for a wide range of application. There are two types of headers, half headers and full header. Half header. The half header take two input bits and produce two output bits, whereas full header take three input bits and produce two output bits. Now we will discuss half header more thoroughly. Half header add two binary digits. It produces two inputs as carry and sum. As you can see in the diagram that we give two input A and B and their output are S and C. Point number 2. XOR put in both input produce sum and produce carry. Look at the diagram again. AB we use as input and they are connected to a gate, a XOR gate, and it produces sum that is donated by S. And you can see there's one more gate that is AND gate, which is used to multiply two input, and its output is C, which is carry. Now look at point number 3. Design half header logic gates. When you add one binary digit, you can use half header. In truth table, sum is the output and carry is the carry out. Now look at the truth table. We give 4 input in A and B. In A we have 2 0 and 2 1, and in B we have 0 1 0 1 alternatively. Now the output. Look at the sum. When we have 0 0 in AB, the sum is also 0. When we have 0 1 in AB respectively, then the sum is 1. And when we have 1 0, the sum is again also 1. And when we have 1 1, we have 0 as a sum. So this means that when we have both same numbers in AB, so their sum will be 0 automatically. Now look at the carry out. When the sum is 0, the carry out is also 0. When the sum is 1, the carry out is 0. But when the sum is 0, the carry out is 1. How it's possible? Now look at the truth table. 0 0 when we add 0 0, the sum is 0, there will be no carry, so there is 0 carry. When we have 0 1, the sum is 1, simple, there is no carry. But when we add 1 1, then it becomes 10 automatically. So we have 0 in sum and carry in 1. Now we will look at the full header. Generate sum of 3 inputs and carry value. First inputs are A, B, just like the half header, but the third input is carry SIN. Now point number 3. In the truth table, S is XOR input A input, sum returns with B in half header and input sum in. Suppose 2 and 3 outputs are high Cout will be true. Now look at the diagram. First we give two input AB that are connected to XOR, and that XOR gate is again connected to one more XOR gate. And okay, now look at the third input, that is CIN. CIN is connected to that second XOR gate and produce the sum, and CIN is also connected to two AND gate, and then it produce output as carry by the help of OR gate. Now look at the diagram. We have 2 outputs and 3 inputs. First we have 0 0 0, so its carry and sum both are 0. Okay, now look at the last one. When we have all inputs 1 1 1. Okay, when we add 3 1, so its answer is 11. So 1 is in the sum and the other one of that 11 will be put in the carry. This is how full header works. Now we will discuss some differences of half header and full header. In half adder we have two inputs, and in full adder we have three inputs. In half adder the inputs are A, B, and in full adder the inputs are A, B, and C in. The output in half adder is sum and carry, and in full adder we have sum and carry out as our output. Half adder carry, previous carry don't use, but in full adder we do use previous carry. Components, the components we use in half adder are XOR gate and AND gate, whereas in full adder we use two XOR and two AND and one OR gate. Okay, we use half adder in calculators and in computers, whereas we use full adder in digital processor that are like, we have chips in our CPU. If you ever open that thing, so they are small chips, so that are digital processor.